So the previous video from today's lesson finished us off on chapter 6, and now we're going to move into chapter 7, which is quadratic relations. And every quadratic relation will have the standard form of y equals ax squared plus bx plus c, where a, b, and c are just numbers. So it could be, 2x squared plus 3x plus 4. So the numbers aren't important except that a cannot equal 0. It can't equal 0. What would happen if it equaled 0 is you have y equals 0x squared plus bx plus c, and that would be y equals bx plus c. And hopefully this looks familiar to you in that this is a line. Okay, a line is not a quadratic. It's not what we want. So a always has to be greater than 0. And then here you have the x squared. And this is a degree of 2. Okay, so the degree of a parabola is 2. And that just means that the greatest exponent is 2. Okay, so the numbers can change, a, b, c can change, but the degree has to be 2 and a has to be greater than, or it can't be 0. It can be greater or less than 0. So you'll see that the shape of a quadratic function is a parabola, which looks sort of like that. Okay, and a parabola can open up or down. So this parabola right here, this will open up. Okay, so it looks like a smile, sort of. So smiles open up and frowns open down. And the lowest part of a parabola, if it opens up, or the highest point if it opens down. Just one second. Sorry about that, my computer just froze and crashed on me. So anyway, our vertex, which is not up there, which is this point right here, is the lowest or highest point. So on a parabola that opens up, it will be the lowest point. On a parabola that opens down, it will be the highest point. And this quadratic relation for this particular parabola is y equals x squared plus 0x plus 0, or y equals x squared. And we're going to go over how you would figure that out in just a bit. So a parabola has a vertical line of symmetry, which means that it can be separated or mirror imaged down the vertical line. So when you draw your vertical line of symmetry, you'll draw it down the middle like a mirror image. And the highest or lowest point on the graph, which again, remember, is called the vertex, will always lie on its vertical line of symmetry. So the vertex will always be at the bottom or the top of that line of symmetry. And so in this case, if we go down, it crosses the x-axis at 5. So our line or axis of symmetry is x equals 5, because it's a vertical line. And so when we were doing it before, remember that a vertical line is x equals 5 and a horizontal line is y equals whatever. And so the vertex also lies on x equals 5. So it's on that line. And the way we know it's that we've drawn the vertical line of symmetry is if we compare 2 points with the same y coordinate. So if you go up the y-axis, there is equal distance between each point. BTWN is between each point and the line of symmetry. So if you see I've drawn 2, so say we go across at 6, so between 5, so if you go down 6, or at y equals 6, from the point of symmetry, if you go left, it will be 1, 2, 3, so just over 3, because it will land just over there, and then it should do the same over here. Okay, and same if you do, say, y equals 1 and you go across. Okay, you'll go down and go down. There should be the same distance between the line of symmetry, or the axis of symmetry, and the edges of the parabola. Okay, so how do we know if it opens up or down? We look at A. Okay, so remember we have y equals ax squared plus bx plus c. A tells us if our parabola opens up or down. So if A is positive, the parabola will open up, and if A is negative or less than 0, parabola will open down. So let's try and see what we mean. So we have y equals x squared, and so remember that there's going to imaginarily be a 1 there, and so A equals 1, and this is positive. So we'll make a little chart with x and y and just plot some numbers. So let's do x equals -2, -1, 0, 1, and 2, our standard numbers that we do. So if x is -2, you have y equals -2 squared. Y will be 4. If x is -1, y will be 1, so -1 squared is 1. It will be 0 if they're both 0, and they'll have 1 and 4 again. And if we plot those points, so we have 0, 0, we can go 1, 1, and -1, 1, and then we'll go 2 and up 4, and -2 and up 4, and you'll join it, and you'll see there's your parabola, and it is in fact opening up. And so this opens up. And then if we try it with a -x squared, so here A equals -1. So this is a negative value. We'll make our chart again, and we'll use the same values: -2, -1, 0, 1, and 2. Now remember that when we do here so y equals -2 squared. Okay, so the negative is in front of the x squared, and x squared would be a unit there. And so this will equal -4. So -2 will give us -4. And then -1 would give us -1. So if we did -1 times -1 squared. 0 still gives us 0. +1 will give us -1. Right, so if we have -1 squared, and then +2 gives us -4. And then if we plot those points, so again our vertex will be at 0, 0, and then we'll go down. So 1, -1, -1, -1. And 2, -4, and -2, -4. And there's your parabola, and it should pass through the points. And this parabola opens down. Okay? And so your vertex in both, and here's your vertex, here's my lowest point, so that's 0, 0. And here, it's my highest point, but it's still 0, 0. And what we can do is, in standard form, we can break this down a little bit. So for A, remember our restriction is that A cannot equal 0. And then, so that's 1. If A is greater than 0, so if it's positive, our parabola will open up. If A is less than 0, or a negative value, our parabola will open down. If you change B, you change the location of the axis of symmetry. Okay, so here, in these two that we just drew, our axis of symmetry is at x equals 0. We saw a previous example where it was x equals 5. So changing B changes the location of the axis of symmetry. So where is the parabola mirror imaged? And the constant term shows the parabola's y-intercept. So it's the same as the b in y equals mx plus b, but now it's a c. So if we are given the quadratic relation that y equals 2x squared plus 3x minus 6, the parabola crosses the y-axis at y equals -6. And as a point, that would be 0, -6. And a quick note about domain and range. All quadratic functions are x is all real numbers and y is all real numbers. But there will be a maximum or minimum value for x. Or sorry, for y. So a maximum or minimum value for y. And sometimes when we model a problem with a quadratic function, we may restrict domain and range. So when we model a problem with quadratic function, we may restrict domain and range. Okay, and sorry that this is not quite the short video I want it to be, but let's just do some examples together. So predict the values of A and C. Also estimate the line of axis of symmetry. So let's talk about what we know about this. Okay, so remember that A will tell us if it opens up or down, and C will tell us the y-intercept. So we know that this, we look at it, it opens up. So A will be greater than 0, and it will be a positive value. The axis of symmetry, if you look, it mirror images right over the line x equals 0. Is x equals 0. And then if we look at where it crosses the y-axis, so our vertex looks to be at the origin, so at 0, 0. So it crosses the y-axis, at 0, 0. Therefore, c equals 0. Okay, so let's look at this guy. It opens down, which tells me what about my a value? My a value will be less than 0. So it will be a negative value. It crosses the y-axis. If we look, we can see it crosses at the point 0, 6. So therefore c will equal 6, right? Because c is the y-intercept. So where does it cross y? It crosses y at point 6. And then our axis of symmetry, if I go down from my vertex and I carry it down, and your line can be straighter than my line, looks like my axis of symmetry is at x equals -1. Okay, let's look at number 3. So we're opening up. So a is greater than 0, and it's a positive value. Where does it cross the y-axis? Crosses the y-axis here at -1, so crosses y-axis at point 0, -1. So therefore c equals -1. And our axis of symmetry, and again, if you go from your vertex and just kind of try to split the quadratic in half, if your quadratic didn't move like mine does, the axis of symmetry is x equals 1. And look at yours, because your graph doesn't move sometimes when you touch it like mine does. So if we look at which of the following relations are quadratic, and remember, and just like y equals mx plus b, until you have this memorized, write up your quadratic relation. So your general form, y equals ax squared plus bx plus c. And remember that we need a value for a. So if we look at the first one, y equals 3x minus 8. Look at our degree for x. This is a degree of 1. But for a quadratic relation, we need a degree of 2. So is this a quadratic relation? No. This is what? This is actually a linear function. So this will give you a line if you graphed it. Here we have y, so number 2 is y equals 4x squared minus 6x plus 2. So let's see, I have y equals, I have an ax squared minus bx plus c. Do I have a degree of 2? Yes. So yes, this is a quadratic relation. Here, 2x plus 1 squared plus 7. At this point, I can't tell, so what I have to do is expand. I have to expand. And I have to get it into, so just like when we had something that looked like 5x plus 2y equals 3, and you had to get it into y equals mx plus b form, here we're going to have to get it into ax squared plus bx plus c form. So we have 2x plus 1 times 2x plus 1 plus 7. And remember, when you rainbow out, you have to multiply everything by everything. Okay, so we have 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And then 1 times 1 is 1. And then we'll have our plus 7 just keeps pulling down with us. So if we combine like terms, we only have 1x squared, so we'll have 4x squared plus, and we have a 2x and a 2x. So 2x plus 2x is 4x plus, and then we have our two numbers, 1 and 7. 1 plus 7 is 8. So here is our relation. Is this quadratic? So we have a 4x squared plus 4x plus 8. So yes. And then again, we'll have to expand here. So expand out. So you have x squared plus 2x minus 2. X squared plus 2x minus 2. There's no like terms. Is that a quadratic? Yes, it is. Okay, so you can do your textbook questions on page 360, number 1 to 6. Okay, so the homework, so do the textbook questions that we saw in the notes. Do these worksheets and the problems. If you didn't already hand them in last week, please hand them in on Tuesday. And we will have a very, very small quiz on Tuesday. It will just be one question. It's going to be very similar to the questions that we looked at on page 334. So I'm going to show you a solution and with a feasible region, and I'm going to want you to tell me the restrictions and the constraints. So the restrictions would be, is it all whole numbers or all real numbers? And you'll be able to tell that if it's shaded or stippled. And the constraints will be, can you tell me the linear inequalities that you can see? Okay, so can you write essentially the equations for the lines, for the boundaries? And then I will also ask about the minimum and the maximum. So you have to tell me if it's a hollow dot, then it will be near, the solution will be near that point. And if it's a solid dot, it will be that point. Okay, so look at the questions on page 334. The quiz will only be one problem. We'll do it after break, so not first thing. So if you have any problems, please, please, please come see me. You can come see me Monday after school at 2:30, anytime after 2:30. And you can come see me before school too. So on Tuesday, if you have problems, please try to get here around 8:30 so that I have enough time to help everyone who needs it. And also email me if you're having any problems. Just be very clear about your question, and I will do my very best to answer it. Thanks, guys, and have a great weekend.